All right, so what we're going to talk about today in class is actually performing calculus with parametric curves. So let's just remind ourselves what a parametric curve is very quickly. So last class, we introduced this notion of a parametric curve. And remember, this is not a function like we've normally thought of functions. Y is a function of X, one input, one output. Instead, we have these parametric curves that actually don't have to abide by a vertical line test. So as you can see, this vertical line passes through this parametric curve at more than 1 point. So it wouldn't be a function in the normal sense, but we can actually mathematically describe this as a parametric curve where our individual coordinates, X and Y, are themselves functions of this parameter that we're thinking of, like time or a third parameter in general. So we're thinking about this parametric curve, and we're going to start asking ourselves some calculus related questions. So for example, we remember in Calc A, we learned about slopes, tangents, concavity, things related to derivatives. So we're going to think about those same exact ideas today, but apply them to parametric curves. So for example, if we have a point on the curve and we want to calculate, say, the tangent line to this point, we need to ask ourselves, well, how do we compute tangent lines in Calc A? We cared about the slope at this point. And then we could plug them into one of our line equations. So for us, what will actually be useful is kind of the point slope intercept form of a line. So we have y minus y0 equals m times x minus x0. So if we're thinking about, say, creating this tangent line to our parametric curve, like up above, we would define this point as this would be our x0, y0 value. So we already know y0, we already know x0, just based on the point along the curve that we care about. And that last thing we need to figure out is, what is that slope? So this will be the ideas that we discussed today. How do we calculate slope? How do we calculate concavity? And things like that for our parametric curves. We'll also start asking ourselves more calculus B flavored questions like the area under a parametric curve, or how can we compute the length of a parametric curve, or the arc length as well.